All right, good morning, everybody. We're working on part two of the notes. For those of you that are hybrid in class, you are getting this live in class. For my AO kids, you're either going to get this via the video or you may choose to zoom in. Regardless, it will be there for reference. We are covering the hypothalamus and pituitary gland relationship today. Our learning targets are describe the structural and functional relationships between the hypothalamus and the pituitary gland. Discuss the structure of each gland, describing the target and function of each hormone it secretes. All right, so let's go ahead and get started. Your pituitary gland, also known as the hypophysis, to grow under, hangs under the hypothalamus via a stalk called the infundibulum. All right. And it is seated in the sella turcica of the sphenoid bone. Now, we talked about that. That's that little saddle, excuse me, the sella turcica little saddle that the um, pituitary gland rests in. And we saw that when we were looking at the sphenoid bone. I think it was a bonus question when we did the bone practical. There are two lobes of the pituitary gland. There is the anterior, noting that it also is made up of epithelial tissue known as glandular epithelium tissue, and the posterior um, pituitary lobe, which is made up of neural tissue. Guys, this makes this what is referred to as a mixed gland, either by difference in tissue or difference in how they secrete or difference in and the types of hormones such as they are antagonistic to one another. But this is one of the mixed glands. It is part glandular epithelial tissue and it is part neural tissue. All right, the relationship between the two. The hypothalamus produces two hormones that the posterior pituitary stores and releases. So the posterior pituitary does not produce its own hormones. It stores and releases them. So you can see here the hypothalamus. You can see the pituitary. Here, this is anterior. Anterior is front. I'm going to write this up here just so we remember. Anterior is front. Posterior is back. Denoting that front is front, guys, no matter which direction you are facing. If you face to the right, the nose is still pointing to the front. If you face to the left, the nose is still pointing to the front. It doesn't matter which direction you are facing, front is still front. That's very important. All right, so let's take a look at this. You can see how the pituitary hangs off of the hypothalamus via the infundibulum. You can see the anterior and posterior pituitary, the different types of tissue that it is made of. And right here, you can see right here, what we're looking at is the sella turcica. Right here, this is the hypophyseal fossa, or the sella turcica right here, that sits, that saddle that sits in the sphenoid bone. All right, now, notice that the hypothalamus, you have the neurons that produce the hormones released from the posterior pituitary. So this is nervous tissue. So this is they're important, guys. This is neural stimulation. You'll remember when we talked about the three different types of hormone release that happen in the endocrine system, and we said one of them is neural stimulation. This would be one of those. The posterior pituitary is made up of neural tissue, therefore it's neural stimulation. All right. Now, we're going to start with the anterior pituitary gland. Traditionally called was traditionally called the master gland, but now the hypothalamus is called the master gland because it controls the pituitary. This is basically relatively new within the last 4 to 5 years, because up until about 4 to 5 years ago, we referred to the anterior pituitary as the master gland because of all of the hormones that it produced and what it controlled. But now we look at the hypothalamus as the master gland because it controls the pituitary. Most of the hormones produced by the anterior pituitary are what we've referred to as tropic hormones. They regulate other endocrine glands. It's that boss-employee relationship that I talked about in the first video. All right, so let's take a look at the hormones. First hormone produced is called growth hormone. All right, the target, muscles, bones, liver, and cartilage. I'm going to do something here a little bit different. Target, muscles, bones, liver, and cartilage. Let's see. All right. Function, skeletal and cellular growth, increased fat breakdown, and increased blood glucose. All right. Now, go back and do this. All right. Now, let's talk about some homeostatic imbalances. First one of these is called gigantism. It is hypersecretion of GH in childhood. I'm going to write that. Still active epiphyseal plates. In other words, you're still growing. That's an important statement. Still active epiphyseal plates. All right. Now, the next one is called acromegaly. That is hypersecretion of GH in adulthood. Okay, now, this is post-epiphyseal plate closure. All right, that's the difference, guys. All right, so prior to closing of the epiphyseal plate, you're still growing, which means the bones can increase lengthwise, and that's how you get gigantism. If you happen to have acromegaly, which anything that could cause the pituitary gland to secrete excess amounts of growth hormone, after your epiphyseal plates have closed, the only way you grow is outward. So your bones grow in oppositional width. So you would get forehead bossing, prominent forehead, prominent cheekbones, really thick, big hands, thick, big fingers. If you've ever watched The Princess Bride, you've seen the character Fezzik, played by Andre the Giant. Andre the Giant had acromegaly. Also, if you go into your notes section, I think I have put the PDF out there. If not, I will. The PDF of the PowerPoint of these notes. And the reason I did that is it's got some interesting pictures of these disorders in there. All right, the third one of these guys' disorders is called pituitary dwarfism. And that is a hyposecretion of GH in childhood. All right, hyposecretion. So you get pituitary dwarfism. Think the Munchkins from The Wizard of Oz. Pituitary dwarfism. All right, the second hormone produced by the anterior pituitary is called thyroid stimulating hormone. It is called TSH for short, or sometimes referred to as thyrotropin because it is a tropic hormone. It is a tropic hormone. Oops. It's a tropic hormone. Its target is the thyroid gland. Its function is to stimulate the thyroid gland to secrete its hormones. So that's that quote unquote, guys, boss employee relationship. The anterior pituitary secretes TSH, which then tells the thyroid gland to produce its hormones. And there are two hormones that are produced by the thyroid gland. All right, the third hormone that is produced, third of six, that is produced by the pituitary gland, is known as the adrenal. This is one of my favorite names, guys, because of how long and convoluted it is. Adrenocorticotropic hormone, also known as ACTH. Yes, abbreviations are allowed on your flashcards and they are allowed on your chart as long as they are the appropriate abbreviation. So, adrenocorticotropic hormone, or ACTH, it is a tropic hormone. Its target is the adrenal cortex. Its function is to stimulate the adrenal cortex to secrete its hormones. Again, boss-employee relationship. Now, the fourth hormone that is produced by the anterior pituitary is called prolactin, or PRL. Its target is the breast. Its function is it promotes lactation. All right, now that's four. The next group we refer to is gonadotropic hormones, but there are two of them and they target two different areas. So while we call them gonadotropic hormones, we take them as two separate hormones. So gonadotropic, knowing that they're tropic, gonadotropic hormones, and they're tropic hormones, they target the gonads. So we're just going to kind of write that out there. The target is the gonads. Now, obviously that would be ovaries in females and testes in males. So specifically, the first one we want to look at is known as follicle stimulating hormone, or FSH. Now, target is, it is a tropic hormone. Target is the gonads, ovaries in females, testes in males. Now, follicle stimulating hormone. Now that sounds like it'll only target female gonads, but it does have functions in both males and females. Now, the function is separate. Function in ovaries, it stimulates follicle development and promotes estrogen production. In males, targeting the testes, the function in the testes is stimulating sperm production or sperm development. All right. The sixth and final hormone of the anterior pituitary is known as luteinizing hormone, or LH. Again, it is a tropic hormone. There's that boss-employee relationship. Its target also is the gonads, ovaries and testes. Function. In ovaries, it triggers ovulation, stimulates both the production of estrogen and progesterone. In males, in the testes, it promotes testosterone production. So this is that type of hormonal stimulus that we talked about in part 1 of our notes. You have your hormone released caused by another hormone, which is tropic. So in this case, we said the anterior pituitary, in this case, as we said, produces TSH, which targets the thyroid gland, ACTH, which targets the adrenal cortex, and then either FSH or LH, which targets either the ovaries or the testes. All right? So the hypothalamus controls the pituitary gland. In this case, there are 4 trophic hormones that target another gland and tell them to release their hormones. Okay? So you have that cascading effect there. All right, so let's move on to the posterior pituitary gland. All right, remember, the posterior pituitary gland stores and releases. It does not produce its own hormones. It is only a storehouse, okay? So the first hormone is called oxytocin. We talked about this at the beginning of the year when we were talking about positive and negative feedback. Its target is the uterus and breast. Function: stimulates uterine muscle contractions, initiates labor, and the milk production or letdown reflex. Very, very important, ladies and gentlemen. And we're going to find another color for this. I'm going to make this green. It is controlled by positive feedback for homeostasis. This one hormone controls 2 of the 3 positive feedback mechanisms that we discussed. Oxytocin controls uterine contractions and it controls breastfeeding or lactation. All right, this one hormone has 2 of the positive feedback mechanisms that we discussed earlier in the year. All right, our last hormone here that is produced by the hypothalamus but stored in the pituitary gland and released by the posterior pituitary gland is antidiuretic hormone. All right. The target is the kidneys. The function is to stimulate the kidney tubule cells to absorb water from forming urine. So in other words, it conserves water back in the body. The term diuresis means urine production. And antidiuretic inhibits urine production. All right, so this helps keep from dehydration. Excessive urination can cause dehydration. So an antidiuretic will inhibit urine production. Now, homeostatic imbalance. Diabetes insipidus. This is different from type 1 or type 2 diabetes. That's known as diabetes mellitus, sugar diabetes. This deals with water balance. What you have is a hyposecretion of ADH that causes extreme thirst and excessive urine output. In other words, there is too little hyposecretion, too little ADH. All right, let me charge for a second, guys. It seems like my Apple Pencil died. All right, too little ADH, all right, which means you will continue to have excess urine production. You'll be urinating an awful lot, and then that causes extreme thirst. So the downfall of this would be dehydration. Now, Alcohol inhibits ADH secretion. So, jokingly, you've heard it said that people who drink say, "Oh, I have to go to the bathroom a lot." Well, there's a physiological reason for that. ADH secretes is inhibited by alcohol, therefore you will have excessive urination, which will then in turn cause dehydration. That's the hangover effect. It is a vasopressin, all right? It is a vasopressin. You need to look up the definition of vasopressin. Okay, so go back to this, too little ADH, and I want you to define, look up and define vasopressin. All right, that, ladies and gentlemen, is the last of the notes for the pituitary gland. You have a total of 8 hormones that are produced. 6 by the anterior, 2 are stored and released by the posterior, but they are produced by the hypothalamus. So finish these notes and then start on your chart filling in what you need to know is hormone target function. Hormone target function. All right. See you in class, guys. Bye.